There's a single permission inside your Windows 11 machine that, when granted to the wrong application, hands that application something that no visitor to your home, no colleague at your office, and no stranger on the street could obtain without your explicit cooperation and awareness. Not access to a folder of files that you could review, assess, and decide whether to share. Not a one-time capture of a specific piece of information that has a defined scope and a definite end. Something continuous, something invisible in its operation once granted. Something that updates in real time with every action you take on your computer, and that builds, over the hours and days and weeks of its active operation, a picture of your computing life, whose completeness approaches what a surveillance professional watching over your shoulder would be able to describe after months of observation. The picture includes what applications you use and for how long, what content holds your attention and what you scroll past, what you type and what you delete before sending, what you search for and what you find, what time of day your attention is sharpest and what time of day your activity indicates stress, distraction, or personal difficulty, the rhythm and character of your entire cognitive relationship with your computer, captured in real time, accessible to an application you may not remember installing and may not think about as something with access to this category of your private life. The permission is called Background App Activity Access, and it is enabled by default for a list of applications on your Windows 11 machine that, if you have never specifically examined and adjusted the permission settings, is almost certainly longer than you would find acceptable if you read it with full awareness of what background activity access actually allows the applications on that list to observe about you. This is not a permission that most Windows users have ever thought about as a privacy concern because its name does not communicate what it enables in terms that make its privacy implications intuitively clear. Background app activity sounds like a power management feature. It sounds like something that controls whether applications can refresh their content when you're not using them, whether email applications can check for new messages in the background, whether calendar applications can update their data without requiring you to open them manually. These are the legitimate and genuinely useful functions that background activity access enables, and they are the functions whose descriptions appear in the user-facing documentation that most users who encounter this permission category encounter. What the documentation does not describe with equal clarity is the other dimension of what background activity access enables. Applications with background activity access can monitor your foreground application usage continuously while running in the background themselves. They can record your active application focus duration, your window switching patterns, your input activity levels, and the behavioral signatures of your computing sessions in ways that build the kind of detailed individual behavioral profile that the prior coverage in this series has documented Windows' own surveillance infrastructure building through its built-in systems. The difference between Windows' own behavioral surveillance and application-level behavioral surveillance through background activity access is not a difference that benefits the user. Third-party applications with background activity access are operating outside the limited visibility Microsoft's privacy dashboard provides and are transmitting what they observe to servers whose data handling practices, retention policies, and commercial applications are governed by those applications' own privacy policies rather than Microsoft's, policies that receive even less user attention than Microsoft's own policy receives. Here's exactly what background activity access enables applications to observe about you and how that observation capability is used commercially. Here is which applications have this permission on your machine right now and how that list became as long as it is without your active awareness of each grant. Here's the specific evidence from application behavior analysis that documents what applications with background activity access actually do with the observation capability it provides. Here's why the permission architecture that Windows uses for background activity access is specifically designed in ways that maximize permission grants while minimizing user awareness of what is being granted. Here is what the regulatory response to background activity access abuse looks like across the jurisdictions that have been examining it as a component of the broader Windows privacy investigation. Here is what happens to the data that applications collect through background activity access once it leaves your machine. And here is the complete process for auditing every application on your machine that currently holds this permission and removing it from every application whose surveillance capability you did not knowingly and deliberately authorize. Understanding what background activity access actually enables requires understanding the technical architecture of how Windows manages application visibility into system state, because the permission's privacy implications flow directly from what the Windows application programming interfaces that background activity access unlocks provide to applications that hold the permission. Applications running in the foreground of Windows, the applications you can see and are actively using, have access to their own operational data as a basic function of running. They know what you are doing within them because you are using them. The privacy concern with foreground applications is about what they do with what you do within them, a concern addressed through application-specific privacy considerations rather than through Windows permission management. Applications running in the background, the applications that are technically running on your machine but not currently visible or actively being used, have a different default access state. By default, background applications are not supposed to have visibility into what is happening in other applications, what the user is currently doing, or how the user is behaving across their computing session as a whole. The background state is supposed to be a reduced capability state where the application exists in memory and can perform its own operations, but cannot observe the user's activity in other application contexts. Background activity access is the permission that selectively relaxes this isolation for specific applications. Applications with background activity access, granted, can query system-level activity APIs that report foreground application focus, user input activity levels, session state information, and behavioral patterns that are visible at the Windows system layer, rather than within any specific application. These APIs were designed for legitimate purposes, including accessibility features that need to understand user activity context, productivity tools that provide cross-application workflow assistance, and system management utilities that need activity information to make intelligent decisions about resource allocation. The same APIs that legitimate accessibility features use to understand user activity context for benign purposes are the APIs that surveillance-oriented applications use to build continuous behavioral monitoring capabilities that their privacy policies describe in language sufficiently vague to cover the monitoring without describing it in terms users would recognize as surveillance. An accessibility application that monitors foreground focus to provide contextual assistance, and a commercial data collection application that monitors foreground focus to build behavioral profiles. For advertising targeting, are using the same Windows APIs through the same background activity access permission. The permission architecture does not distinguish between benign and surveillance uses of the APIs it unlocks. The commercial applications that have been most aggressively exploiting background activity access for behavioral data collection purposes are concentrated in several specific categories, whose widespread installation on Windows machines and whose business models create strong incentives for continuous behavioral monitoring. Free applications that monetize through advertising targeting have the most direct financial motivation for collecting continuous behavioral data, because the richness of behavioral data they can collect directly determines the precision of advertising, targeting they can provide to their commercial customers, and therefore the revenue they generate per user. Applications in this category include free games, free utilities, free productivity tools, and free media applications that are installed by large portions of the consumer Windows user base precisely because they are free, without awareness that the payment for their free functionality is continuous behavioral monitoring through background activity access. Browser extension applications represent a specific background activity access risk category that receives less attention than it deserves, because browser extensions are experienced by users as browser features rather than as separately permissioned applications, obscuring the fact that many browser extensions with aggressive data collection practices hold Windows-level background activity access, in addition to the browser-level access that their extension permissions cover. A browser extension that holds both browser-level access to browsing history and Windows-level background activity access through background app permissions has surveillance capability that spans your browsing activity within the browser and your computing activity outside it, building a behavioral profile that is substantially more complete than either access level would provide independently. Gaming peripheral and hardware utility applications represent a background activity access risk category that gaming-focused Windows users are particularly vulnerable to, because the applications that manage gaming mice, keyboards, headsets, and monitors are typically installed during hardware setup, immediately granted the system access they request as part of a hardware configuration process that users experience as necessary technical setup rather than as a privacy decision, and then forgotten as background processes that run continuously and silently while the user focuses on gaming. Several major gaming peripheral utility applications have been documented through privacy research as using the background activity access they hold for hardware management purposes to additionally collect and transmit behavioral data about gaming session patterns, application usage outside gaming contexts, and system activity profiles in ways that their end-user license agreements cover in language users do not read during hardware setup. System optimization and performance utility applications are among the most widely installed background access holding applications on Windows machines because they are frequently bundled with hardware driver packages, frequently promoted through download sites as solutions to common Windows performance problems, and frequently installed by users who are experiencing genuine performance issues and are willing to grant broad system access to applications that promise to address those issues. The background activity access that performance utility applications hold for their legitimate performance monitoring functions provides surveillance capability, that commercially motivated applications in this category may use for behavioral data collection alongside or instead of the performance optimization purposes their marketing describes. The permission grant process that populated the background activity access list on your machine with applications you may not remember consciously authorizing is itself worth understanding, because the process's design reflects the same organizational philosophy that characterizes Windows' own privacy architecture. Microsoft's Windows permission system was designed to balance security and usability in ways that have been continuously adjusted toward usability at the expense of security, as user friction complaints have influenced design decisions over successive Windows versions. The current background activity access permission grant process on Windows 11 involves permission requests that applications present during installation or first launch in dialog boxes that appear as part of the application as setup or onboarding flow, rather than as isolated permission requests that users evaluate outside the context of the application experience they are trying to access. The placement of permission requests within application onboarding flows exploits the same psychological dynamic that prior coverage has documented in the context of OneDrive, folder backup consent flows, and Copilot setup prompts. Users who are in the process of setting up an application they want to use are in a goal-oriented state where permission request dialogues are experienced as gates between them and the application they want, rather than as privacy decisions whose independent evaluation is worth the interruption of the setup flow. The dialog box design for background activity access requests further reduces the probability of user rejection through specific visual design choices that the user experience research literature characterizes as choice architecture. The permission is described in language that emphasizes the beneficial functionality it enables rather than the surveillance capability it provides. The Accept button is visually prominent and positioned in the location that users' learned interface behavior directs them to click to proceed. The Decline option, where it exists, is visually recessive and often labeled in ways that imply declining will prevent the application from functioning correctly. Rather than simply preventing it from accessing background activity data, it does not need for its core functionality. Users who click Accept are not making an informed privacy decision. They are following the path of least resistance through a setup flow using the interface navigation reflexes that years of Windows application installation have conditioned. The cumulative result of this permission grant architecture operating across all the applications a typical Windows user installs over several years of machine use is a background activity access permission list that reflects not the user's informed privacy preferences, but the aggregate effect of hundreds of individual setup flow moments where declining seemed riskier or more effortful than accepting. The list on your machine right now is almost certainly longer than any deliberate privacy. Assessment of which applications genuinely need continuous observation of your computing behavior would have produced. The commercial data pipeline that background activity access feeds, once applications collect behavioral data through it, operates through a third-party data broker ecosystem that is developed specifically to aggregate, normalize, and commercialize behavioral data from multiple application collection points into unified individual profiles that advertising platforms, financial services, insurance companies, and other commercial buyers purchase for targeting and risk assessment purposes. An individual application, as background activity data collection, is a small piece of a larger commercial architecture that assembles those pieces from many applications across many users into profiles whose completeness and commercial value substantially exceed what any individual application's collection alone would represent. The data broker aggregation dynamic means that the privacy risk of any individual application is background activity access is not well represented by examining only what that application does with the data it collects, because the commercial value of the data may be realized not through the collecting application's own use, but through its sale or sharing with data brokers who assemble it with data from other sources into profiles that the collecting application's privacy policy may describe incompletely. An application whose privacy policy describes its background activity data collection as being used only for product improvement and feature development may simultaneously share that data with data broker partners whose commercial applications are substantially different from the stated product improvement purpose without the privacy policy technically misrepresenting the collecting application's own use. The regulatory response to background activity access abuse has been developing through the consumer protection and privacy enforcement frameworks of multiple jurisdictions, with increasing specific focus on the permission as a distinct category of concern, rather than as one element of broader Windows privacy investigations. The Federal Trade Commission's enforcement actions against mobile application developers who misused activity monitoring permissions on smartphone platforms established regulatory precedent and enforcement methodology that is being applied to Windows background activity access, with adaptations appropriate to the desktop platform context. Several FTC enforcement actions that preceded the current Windows privacy investigation wave documented the Commission's willingness to treat misleading permission request practices and undisclosed data. Collection through granted permissions as unfair and deceptive practices, warranting significant financial penalties and mandatory operational changes. European data protection authorities have been examining background activity access permission practices in the context of the GDPR requirement that consent for personal data processing be freely given and specifically informed. The freely given requirement creates a specific challenge for permission grants obtained through application setup flows, where the implicit pressure to accept permissions to access the application the user once installs is present in ways that may compromise the genuine freedom of the consent. The specifically informed requirement creates a specific challenge for permission descriptions that emphasize beneficial functionality while omitting surveillance capability from their user-facing description. Both challenges are elements of formal investigations that German, French, and Dutch data protection authorities have been developing as components of broader Windows platform privacy cases. The UK Information Commissioner Dre's Office Technical Audit of Windows 11's application of permission architecture has included background activity access as a specific examination area, with attention to whether the permission descriptions that Windows presents to users at grant time accurately represent the full scope of what the permission enables applications to access. The ICO's technical audit findings on this question have characterized the gap between permission descriptions and permission capabilities as representing a transparency deficit whose GDPR implications are being incorporated into the formal enforcement proceedings that the ICO's Windows investigations are approaching. The enterprise security dimension of background activity access abuse has been generating responses from corporate IT security teams that are distinct from the privacy compliance concerns driving enterprise responses to other Windows 11 surveillance architecture elements. Background activity access, held by third-party applications, creates attack surface that is relevant to corporate security architecture as well as to privacy, because applications with continuous system activity monitoring capability are also applications with persistent elevated system visibility. That represents an attractive target for exploitation by malicious actors seeking to maintain covert access to corporate computing environments. Corporate security teams that audit their application permissions, inventories for background activity access exposure frequently discover applications in their enterprise. Windows fleets holding permissions that were not explicitly authorized through enterprise software procurement processes, and that represent either shadow IT installations or bundled software that evaded application whitelisting controls. The complete audit and remediation process for background activity access on your machine requires examining both the Windows permission settings interface and the application-level background activity configuration to address the permission from both the operating system authorization layer and the application operational layer simultaneously. Begin by navigating to Windows settings using the Windows key and the letter I. Select Privacy and Security from the left navigation panel. Scroll through the App Permissions section until you find Background Apps. The Background Apps permission page is the primary Windows interface for managing which applications can run and perform activity in the background. The page presents a list of applications with toggles showing their current background app permission state. Examine this list with the specific question for each application of whether you deliberately chose to grant this application background, running capability, and whether there is a current legitimate reason for this application to run continuously in the background and monitor system activity when you're not actively using it. For applications whose background running you cannot justify through a current active need, toggle their background permission to off. Be comprehensive rather than conservative in this audit. Applications that you use occasionally but not continuously do not need continuous background running capability. Applications whose background functions you cannot specifically describe and justify represent permissions whose grant you should not be able to account for and therefore should not maintain. After completing the Windows Settings Background App Audit, conduct a more granular examination through the individual application permission categories that provide more specific control than the global background app toggle. Return to the Privacy and Security section of Windows Settings and systematically work through the specific permission categories that background activity access encompasses. Location permissions should be reviewed and revoked for any application that does not have a current legitimate location-based function you actively use. Notification access permissions should be reviewed and revoked for applications that do not need to surface notifications as part of their core function you actively value. Diagnostic information access. The permission that allows applications to access diagnostic data about your other applications should be revoked for every application that is not a security or system management tool you specifically trust with this access. The account info permission category deserves specific attention. because applications with account information access can correlate their background activity observations with your identity information in ways that transform anonymous behavioral data into identified individual profiles with substantially higher commercial value and substantially more serious privacy implications than anonymous behavioral data represents. Revoke account info access for every application that does not have a specific functional requirement for that information that you have verified rather than assumed. Open Task Manager by pressing Control, Shift, and Escape, and navigate to the Details tab, which provides the most comprehensive view of running processes on your machine. Sort the process list by CPU usage to identify processes consuming system resources while running in the background. For any process whose associated application you do not recognize or whose background resource consumption you cannot account for through a legitimate function the application is performing, note the process name, search for it specifically to understand what application it belongs to, and evaluate whether that application's background operation represents a permission grant you made knowingly and maintained deliberately. Use the Windows Startup Apps tab in Task Manager to identify applications that are launching at system startup and establishing their background presence before you have opened or interacted with them. Startup launch, combined with background activity permission, creates the conditions for the most comprehensive continuous behavioral monitoring. Because the application is present and observing from the moment the system is operational. Disable Startup Launch for every application that does not have a specific functional reason to be running before you actively choose to use it. The third-party audit tool that provides the most comprehensive visibility into application permission holdings beyond what Windows Settings exposes directly is Windows' own built-in but rarely accessed privacy dashboard available through your Microsoft account online at Privacy. Microsoft.com. While this dashboard provides Microsoft-centric visibility rather than comprehensive third-party application visibility, it reveals what Microsoft's own applications and services are doing with the background access they hold, and provides a starting point for understanding the full scope of permission-granted access on your machine, supplementing the Microsoft Privacy Dashboard with a third-party permission auditing tool, such as Privacy Sexy, which is an open-source Windows privacy configuration tool maintained by a security-conscious developer community. Provides coverage of permission and background access settings that the Windows Settings interface does not surface clearly. After completing the permission audit and revocation process, establish a permission review practice that applies to every new application installation rather than only to the existing applications on your current machine. When any application during its installation or first launch presents a background activity access permission request, treat that request as requiring specific justification before granting rather than as a setup flow step to proceed through. Ask specifically what function of this application requires background activity access. Determine whether that function is one you actively want. Verify whether the permission description matches the functional requirement you have identified. Grant only if the function is one you actively want, the permission description matches the functional requirement, and you are prepared to monitor whether the application's subsequent behavior is consistent with the stated purpose rather than exhibiting the surveillance patterns that commercially motivated background activity collection produces. The broader significance of the background activity access permission in the context of the surveillance architecture that this series of coverage has been documenting across Windows 11 as multiple data collection systems is that it represents the dimension of that architecture that is most directly exploitable by commercial actors outside Microsoft itself. The telemetry systems, the AI activity monitoring, the file upload infrastructure, the microphone access architecture, all of these represent Microsoft's own data collection from Windows users. Background activity access represents the mechanism through which the Windows permission architecture extends surveillance capability to the full ecosystem of third-party applications running on Windows machines, multiplying the total surveillance exposure of Windows users beyond what Microsoft AA's own systems create into the full scope of what every permission-holding application can observe. The aggregated surveillance exposure of a Windows user whose machine carries a typical application portfolio with typical permission grants, including Microsoft's built-in surveillance systems and the third-party application surveillance enabled through background activity access, is an exposure that no individual system description fully captures because its totality is the sum of multiple simultaneous monitoring operations, whose combined picture of the user's computing life is more complete and more commercially valuable than any individual component would suggest. Microsoft designed the Windows permission architecture with the stated goal of giving users control over what applications can access. The background activity access permissions design, specifically the way its request to dialogues are structured, the way its capability description emphasizes beneficial functionality over surveillance capability, and the way its management interface requires users to proactively audit and revoke grants rather than being presented with clear, ongoing disclosure of which applications are actively using their granted access, reflects the same organizational philosophy that characterizes every other dimension of Windows 11's privacy architecture. The control is technically available. The design makes exercising the control require more awareness, more effort, and more specific technical knowledge than the design of the permission request process that established the grants in the first place. The result of that asymmetry between how easy granting the permission was and how much effort managing its implications requires is the permission list that your machine is currently carrying. The list of applications that can monitor your computing behavior, observe your application usage patterns, and build behavioral profiles from your system activity. That they transmit to commercial data infrastructure whose handling practices you have never evaluated and whose commercial applications you have never been clearly informed about. The permission exists, the applications holding it are on your machine, the monitoring they are conducting through it has been running since each permission was granted. The data that monitoring has produced has been leaving your machine through each application as network connections to servers whose locations, operators, and commercial purposes you do not know. The audit process above is the process that stops it. The permission revocation is the action that takes back access you gave in setup flows you clicked through rather than evaluated deliberately. One permission, granted dozens of times, to dozens of applications, and dozens of setup flows you navigated as obstacles rather than decisions. The applications it armed are watching you right now through the access you unknowingly gave them. The audit is the last line of defense between your computing behavior and the commercial surveillance infrastructure that permission built a window into. Open Task Manager. Open privacy settings. Start the list, because every application on it that you cannot justify has been watching you justify everything else you do on your computer since the day you installed it, and it has not stopped watching since.